Hi, fourth graders. Today our math lesson is going to focus on arrays. And so our I can statement is I can make arrays to solve multiplication problems. So, array. An array is also known as a rectangular array. It is in a rectangular arrangement of elements such as squares or dots organized in rows and columns. So if you look at those two images on the screen, 4 times 6, you could do like 4 rows and 6 columns of dots, or there's a grid on the other side, which is pretty handy when you're trying to solve our multiplication problems. Now, arrays are all around us. So here are some everyday items that you might have seen that are arrays. So the first picture you see looks like some eggs. I could say 2 plus 2 plus 2 equals 6, or I could say 3 rows of 2 eggs, depending on how I look at that. The next picture, this is a Lego piece, and I know fourth graders love Legos. And so you can sit and you can count all those up, or you can count up the number of rows and you can count up the number of columns. So a row goes side to side, and you can think about that as if you're rowing a boat, you're going on a lake or on a river, and you're rowing side to side. So that's just one handy way to remember what a row is. The next picture looks like a candy bar, and I love Hershey candy bars, especially on s'mores. And those are arrays because look, each square is the same size and they fit perfectly together. And they're always like super fun to break off. On the bottom, I see some paint. I also see a bunch of emojis, and I love emojis. So you can see that those are all in rows and columns. I then see it looks like a makeup palette, like some blush you might put on a face. But I see I have 2 rows and I have 4 columns going up and down. I also think of arrays in other spots, so maybe this is going to make it hungry here. I see those chairs, and they are in 3 rows and they have 3 columns. Ooh, I see a vending machine. So you can see that they're in rows and they're in columns because the same amount of snacks are in each row, and the same number of snacks are in each column as well. Next, you're going to see some donuts. So I see that I have 4 columns and I have 5 rows. The bottom kind of looks like a checkerboard or a chessboard. And you can kind of see that each of those squares, so we have 4 rows and we have 3 columns. A parking lot. This actually is considered an array as well. However, it's just 1 row and there's only one thing in each column. So this would be 1 times 6. Okay, it's a little tricky. And the last one is some apartment building windows. Notice I have 3 rows and I have 5 columns going up and down. So next time you're, outside and looking around, try to find some arrays, maybe in your house as well. So when you multiply, think of the multiplication symbol as having the meaning of rows. Okay, so for example, the fact 3 times 6 would actually mean 3 rows of 6. So 3 is going to be your first number. So I would be drawing 3 rows and I'd have 6 symbols or whatever you're using in each column. So I could say 3 rows of 6 symbols equals 18 symbols, or 3 times 6 equals 18. And so what you notice about those pictures you just saw is symbols are objects that are arranged in neat rows and columns. Those are called arrays. Like if I think of egg cartons fit perfectly into a rectangle. And there's not like a random egg sticking out, okay? So those arrays are always neat and organized. So I can use these arrays though to help solve multiplication problems. So for example, if I did 3 times 4, I would draw this out and I would do 3 because 3 means rows and the 4 means the columns. So I could take those, and to get my product, I could actually draw those lines in and count hollow out squares. Or if I'm getting more advanced in multiplication, I could get rid of those squares in the middle and know that 3 times 4 equals 12. This is called the area model of multiplication as well, because area, if you remember from 3rd grade, is going to be the amount that is inside of our shape. So for this one in particular, I'd be thinking there are 12 units inside this rectangle. And that's also going to be my product. So if I were to tell you to make an array, we would label the factors and we would write a multiplication equation. So let's say I have some graph paper. I'm going to do 4 rows and I'm going to do 5 columns. I could sit and count how many squares there are, and that would get us to 20 units. 18. I can do these in many different ways, okay? So I have the number 18. And I try to do this in a couple different ways. So I could do 3 rows of 3 rows with 6 columns. I could have also done this differently and done 6 rows of 3 to get that. I also know that 9 times 2 is 18 and 2 times 9 is 18. So that would be another kind of array that I could make, but I'm still going to get to the same answer. I can even do 1 row and 18 columns or 18 columns of 1. So 21, again, 21 you can do in several ways. You could do 3 rows of 7 and count how many squares, or you could do 7 rows with 3 columns, and you're still going to get to the same answer. So my factors, 3, 7, 3 times 7 equals 21, my product or my multiple. So I'm going to have you look at each array, count the symbols in each row and column carefully, and then write the multiplication fact for each. So I'm going to help model you through this first one. I could count 1, 2, 3, 4. So rows go side to side, just like you're rowing a boat side to side on a lake, of how many columns. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So I could say there are 4 rows of 8, and I could count all those up and get to my answer, which would be 24, correct? So I would say 4 times 8 equals 24 for the first one. So follow the directions from your teacher to answer those questions. And to wrap it up, again, using arrays can be really handy for multiplication. And whenever you use an array, you want to make sure that it is a perfect square or a perfect rectangle, okay? And that is how you can use arrays to help solve your multiplication problem.